welcome. Thanks for joining us today. We know your schedules are full, so we really want to appreciate your time. Today's session is kind of a hyper-focused session. We're looking at a product called RealityComposer, which helps with spatial composition of multiple different types of data sets. The goal is to wrap up in about 25 minutes with a few minutes for Q&A. Drop your questions in the chat as we go, and if time permits, we'll kind of work them into our flow or answer them at the end. Phil, can you go ahead and introduce yourself?
Yeah, sure. I'm Philip. I'm project manager at Prevu3D. So I'm looking forward to present you that new capability of Composer. And like Jay mentioned, now we will do those type of mini project demo month over month to introduce you on and do like a deep dive on a specific feature. So I think it will be very beneficial for the community to understand those capabilities that we have in the project.
And I'm Jay. If you guys don't know me yet, I'm the Director of Customer Success at Prevu3D. I'm here to assist Phil and help illustrate how these features come to life and discuss how these features can be incorporated into your real-world workflows and day-to-day operations.
Great. Before we dive in, I think we should prompt a small poll to get some engagement from the community and basically get your opinions on where you see RealityComposer being beneficial for your current workflow. So we will show up a couple of different potential answers that you have. The first one is combining different technology together, such as terrestrial scanners, SLAM-based devices, drone scans, and photogrammetry. The other one is like clipping areas of your scans. The other one is like cleaning up artifacts. And those are all challenges that we see in the market currently and people are facing on a day-to-day basis when they are handling reality capture data. So I'm really curious to know which component is the most interesting part for you as part of RealityComposer, and we will deep dive into all those different features one by one during that demo. But right now, it would be great to get your feedback about this.
Yeah, so that'll be a live poll. It'll be open through the entire event. So if you want to change your answer, feel free to do so all the way through the end. All right, Phil, you want to show the unified environment and the most powerful aspects of RealityComposer as it brings all your capture methods together, whether it's TLS, SLAM, or drone, LiDAR, photogrammetry into that single environment.
Yep, totally. So let me put my screen up on the stage. There we go. So yeah, I will start. So as some of you may know, what you see currently is Reality Platform. This is where you will store all your reality capture data. You will upload them and manage your sites, access, and everything like that. So over here has a demo. We do have like the Smart Factory from Deloitte as a showcase that contains an RTC360 scan, a VLX2 scan, and we will show how we combine those two datasets together inside the composer. So first of all, I will open up the twin that is kind of the source of truth. That's kind of the container that is the source of truth of the site. So every site has one twin, and that's where we can like compose, add scans, add layers. So I will showcase that. So this is currently the final result from the user perspective, where you see like the scans combined together. As you can see, it's blending well together. It's pretty hard to distinguish currently which part is the RTC360 scan versus the VLX scans. And I will open the Composer workspace to show you what we have done here.
So Phil, this is kind of a way to unify all of those into a coherent model, correct?
Yeah, exactly. Like one of the biggest challenge I would say from combining those different scans together is most of the time you end up with overlaps between your scans, which is totally normal because like those scanners have long range and you can capture like a lot of data and it can create a lot of noise around them. And you will have scan sessions that overshoots between each others. So what we have over here is a way to clip those area for each scans and they dedicate like which layer should be displayed and the order matters. So I will cover that right now. Okay, so what you see on the screen is currently on the left side, like the two different layers. So we have the VLX scans and the RTC360 scan. And basically, those are layers that you can add. So you can, if you have like more scans over time, you can add those layers in here. And the order really matter because I will cover that during the include workflow. But basically, if the first layer that we have over here is the VLX, and on top of it, we have the RTC360 scan. And this is really important to understand because now if I want to, let's say, if I click on the VLX layer, you will see that not the VLX, the RTC360 scan layer over here, this is everything that was captured over here. So everything that you see even in the dark area is the part that was captured with the RTC360 scan. But we decided to only keep this corner and this machine over here from that layer. And the remaining part, we don't care about it, and it will be filled up by the underlying layer that is the VLX scan. So that's why by putting those boxes, pressing done, what you see as the result is those area in green is the RTC360 scan, and the remaining part is the VLX as a fallback layer. So that's kind of the behavior here. When you include an area, the part that are not included will end up falling back on the underlying layers. So if you have like 5 different layers, that same principle applies as well, layer by layer.
So Phil, I think it's important to kind of outline a couple aspects here. One, the data that's in green, that's a total, it's a tripod-based LiDAR scanner. And the data set that's in red, that is a SLAM-based LiDAR sensor. So all of those have a different level of data fidelity. We can also include drone data, and we can also include photogrammetry data into the same pipeline and align it the same way. Now, a couple things in here that Phil highlighted on is the include. We also have the ability to exclude specific data sets as well. So when you select a data set, it brightens up that area. It kind of highlights through the lighting and the shading what area is being utilized. You get a bounding box. And from that bounding box on the right-hand side, you get the options of include, exclude with the tools at the top. So there's a lot of functionality here that you are not seeing just through this quick demo of what we've already established to highlight the kind of the capabilities of the tool in our short time frame. But one thing you can also do is adjust the color. So we have a red and a green. Maybe you don't want to illustrate those. Maybe you want to use more corporate-based colors. So if you select on that, you can pick any shade or any variation of that RGB value throughout there, and then change the opacity of that data.
Yeah, especially when you have like multiple layers, it can be good to have like good contrast between your different layers. So this way you don't mistake them between each other's. So what something that we can do like now together is really adding one extra layer, not a new layer, but adding another part. So let's say from that RTC360 scan, we would like to add this equipment as well. We can come up and use the include box to do so. We can either use the box, or we also have the lasso tool where you can like create a polygon on the floor and scale it. So let's say I just do something quickly. I will zoom out, grab that corner over here, and place the box like this, and press done. And now we see that this part is being included, and we have that has RTC360 scan instead of the VLX layer. So that's the include capacity. And regarding the exclude that Jay described, let's say we see over here inside the VLX scan that there's some noises like that. There's like a floating bubble over here, and this is typical when you look at scanning data. There's sometimes some noise, maybe something was moving during the scans or reflection occurred. So those are typical artifacts that we can see times to times, and maybe we want to get rid of those like small fans over here. So one thing we can do is select that layer, like that I just clicked on the blue one, and now this is the VLX scan, and we see that bubble, and we can go in the exclude mode. And inside the exclude mode, you will see that already we see those area being hidden because we have the RTC 360 layer on top that says this area would be removed from the Navis VLX layer. So what we can do is come up and add an exclude box for that specific that floating bubble over here, like this. Yeah, I did wrap it all. Press done, and now as you can see, that floating bubble in the result is not there anymore. So you can quickly clean up your scan from artifacts like this, and it's like instant, or even undesired noise. Like for instance, I could decide to clean up over here. There's like some noise outside of the RTC 360 scan. We could remove that easily with the same tool.
All right. So Phil, do we have any other data sets we're going to add to this today, or are we going to look at another example?
I think we could look at another example. I don't have any other layer for that site as we already included those RTC 360 in the VLX one. But if we were to have like new layers down the road, and that's one of the key components, like I know we discussed that earlier today together, we could easily come up today, like go back on that site today, scan it with maybe like a 360 video camera or another VLX, or quickly capture the most up-to-date version of that site, because I'm pretty sure some things changed in between the scan, as this one occurred like 1 year ago. There's probably some stuff that was added or removed, so we could clearly like capture those differences and add and update the composition here.
Sure. So I think one of the bigger values is kind of the elephant in the room for a lot of organizations is, how do I come up with a budget to do a scan, then host it, then do everything else just to get a project off the ground? And I think the photogrammetry pipeline that we're working on, the ability to bring it in here, start with that and generate your mesh from a 360 or some other type of photogrammetry tool really kind of helps expedite a project and get it up and operational before they have the ability to hide that data with a higher fidelity LiDAR sensor, whether it's SLAM or TLS. And then also adding in the external data from a drone is also very beneficial when you start looking at outdoor environments at large scales. So
I think what we can do is switch to the glycol unit. I will discard my change here. I won't save them, but we do have like another example that you may have seen in previous videos or the previous webinar that contains 3 layer this time. And what I will do is the workflow of importing a layer just to show you like how it behaves and how we can apply the mask in those cases. Actually, we do have like a 4th layer. So for those who attended the webinar last time, we only had the drone scan, the VLX one, and the TLS one, and now as you can see, we added like another layer that is much bigger surrounding the environment, and this one is coming from the Google map actually. So it's pretty interesting. It's something that we're currently doing as a proof of concept to bring 3D map on top of the to basically bring a 3D map around the scans. So it's obviously like the quality is a bit lower in those area because it's coming from a 3D map online, but we can see those.
That's another great way to kind of start off a project. A lot of times you're waiting for a scope to be written, or you're maybe waiting for a contractor to get on site. You can certainly start your preliminary layout or your design charrette using the data that's available to you, and then from there you can go out, capture the data with a drone, capture the data with a TLS, capture the data with a SLAM device, and then interchange all that data based on the level of data and data fidelity that you're looking for.
Yep. So we'll just delete a layer as an example over here. And basically, if you press the add layer, you will see all the ones that are currently used from your sites. And this one is available because it's the terrestrial scanner one, and I can press add. And automatically it will align to your existing data if if you have the same coordinates. So basically, in that specific case, control points were used, and everything is geolocalized. So that our RTC360 scan is aligning perfectly on top of the remaining scans. But if you don't have those control points, which I would recommend personally, if you're planning to rescan over time and making sure that your registration is easier, I think it make the process smoother. But we do also have a way, if I select that layer, to do alignments as well. So let's say it was not aligned perfectly. That would come up like this over here. You can still move it uh, where you want. You can fine tune the coordinates from the the right side panel as well, and change the rotations if needed. So that's something really possible as well. I would personally recommend going in top view orthographic to do such alignments because it's much easier when you have like those that top view perspective to align things together. So
Yeah, that's really powerful. A lot of SLAM technology is being utilized, and maybe they're not using control, and maybe the TLS device is being used on control. So if you have those environments, you can certainly mix and match all of that. Typically, drone data is, based on a specific coordinate system. So that's typically less of an issue, but I think this is a really powerful tool to truly align and get all your data registered without having to worry about, am I losing the fidelity by registering it in a third-party application outside of that vendor and then uploading it to a different device-driven upload through our Reality platform?
yeah. And I think this example as well also illustrates well what I was describing earlier, where often your scans will overshoot noise in the other ones. So as you can see, the terrestrial scanners currently is shooting noise on the road, on that building parts, and it's super noisy in those area because the main area that was captured was the middle part here. But still, the range of the scanner was able to pick up points surrounding that area of interest. So that's where the include box come into play, where I can select that layer and say, well, for that layer that I just added in my scan, I want to keep that middle part over here. And let's say I increase it, press done. And now we only keep that area, and we don't have that noise overshooting the other areas. So you can quickly clean up your space like this, and you can still fine tune afterwards if you need to. You can select that, crop a bit more if you need to. And you can also add multiple bugs. So currently I'm doing only one box, but you could decide to pick as well, like this part maybe as well, and press done. And as you can see now, I do have that part and this part.
So that's also important to note that you can tier the data as well. So if you had data at the ground level that you wanted to highlight with TLS, you could also just select that and not pull it all the way up to the top of the platform here. You could then use the include from a different device, maybe a drone, to capture that as well. Specifically when you're dealing with buildings, rooftops, you really want to have the best data available, and maybe you didn't scan it with that device, but you scanned it with a drone. That way, when you're doing the include, if you go all the way to the top of the roof, you potentially override the drone. But now with the include exclude, you can truly highlight all of it.
Yeah. And over here in that example, we had some cars and people's walking in the scans, and we cleaned them up with the exclude tool. We could also remove, let's say over here there's a floating bubble. If we think it's something we would like to remove, we can select the layer quickly and use the exclude functionality, wrap up that bubble, press done, and boom, the floating bubble is disappeared.
That's a really powerful tool. Yeah. Reflectivity is a big issue in LiDAR scanning, specifically in certain use cases around glass and certain reflective materials. So the ability to kind of clean that up in your environment makes it easier for everybody to utilize and enjoy.
Yep.
That's fantastic.
Should we dive into the questions, Jay? Or
certainly are there
I
questions.
see that there's a couple of questions in the chat already. So Mike want to take some of the times. I know
Yeah.
we discussed that we only have like 25 minutes for the webinar, so
Yeah, we're limited. So we're at 20 right now. So I think it's a good opportunity to take a look at some of these questions before we hit a recap. We get, while we take the questions, maybe it's also valuable to put the ecosystem slide up, because that also provides some insight into how we're moving and the features that we're developing.
yeah, no, totally. Like what you see currently on the screen is really our ecosystems. I describe Reality Platform. That is kind of the main entry points where it's kind of your repo for all your data, your Reality Capture data. That's where you will import this. And currently, what we presented during that call is really that RealityComposer layer that allow you to combine and build your source of truths inside your twin. And that is leveraged across our different projects.
Yeah, so certainly. So as we kind of highlighted at the beginning, the Reality Platform is the starting point, kind of the middleware, if you will, for everything, right? So it has a free viewer for anybody that you deem access. That's where you upload all of your point cloud data, some of your mesh data, and other types of data sets if you want to share them out that way. It goes into Reality Platform. From there, you generate your project and your mesh from that point cloud data. And then from there, you actually get the opportunity to push that data directly to the RealityTwin or to the Reality Plan. Reality Plan is going to be where you do your design layouts, your engineering workflows, your design charrettes, your individual concepts. And then the RealityTwin, that's where you're going to kind of align or aggregate all of your mesh data that is generating that project. And then from the twin, you can then also push it down to Reality Plan. So a lot of interoperability within our ecosystem to help with that. We also have the connectors on the side that help stream the data directly to those projects, whether you're dealing with Revit or Plant3D, maybe it's an NVIDIA Omniverse environment, a lot of different functionalities there. And then we also just came out with the beta API that allows you to integrate with different tools. And on the right-hand side, in the upper part, you see SAP, IBM, Aviva, PLC, Siemens, Oracle, Maximo. Basically, any type of webhook, you can go ahead and integrate directly into those tied assets to give you a little bit more of an operational hub and a little bit more data for the long-term strategy of your organization.
Yep. I will put a question over here. Like there's a lot of questions in the chat regarding the alignments component. Basically, yeah, one question over here from Stefan, but I saw in the chat that other people have similar questions regarding control points and all that. How did your friends scans to each other so they lined up? Did you use targets where they're presenting each other's scans? In the two different presentations that we did, the first one with Deloitte Smart Factory, which was done basically is the registration of the RTC 360 scan was done against the Navis VLX scans outside of a software in that solution, but we can still do that same process of a point cloud to point cloud alignments within our solutions with the alignment tool manually. For the glycal units that we presented, this one was using control points. So it was not georeference, but it was using a control network that had local coordinates, and every scans was anchored on those different control points. So everything was lined up together. Like the drone scan was based on those control points, the TLS scans and the SLAM device was anchored on that same control points, which make it much easier because you have more accuracy in a way on your alignments, because it's kind of a, I know, Jay, I think you're a surveyor, so it's kind of an external source of truth for your alignments. And
yeah, always starting with a target-based system is going to kind of help you register all your data. Now, we do have the functionality within the tool, but we want to make sure that the data is where you are, so we can kind of help guide you when you start doing these projects to kind of help educate you on the best workflow, the process, and everything else. So hopefully that answered your question, Stefan. I know we have a limited time slot here, and we're trying to be respectful of everyone's time. If we don't get to all your questions, we will reach out and we will answer all of those questions for you. I think we have time for one or two more questions.
Yep. I do have one over here from Victoria regarding the include box. and I saw other people's in the chat like asking about the overlap, how do we remove it, and things like that. So Victoria really illustrated well where when you include a box on your first layer, it will drop the space, and mention that for the underlying layers, this part's still prioritized on top of them. And she's asking, can we reorder those layers? Because indeed, the order matter in that case. And yes, I didn't show that, but from the left side panels, you can pick and drag and drop the layers to change the order easily. And as you do that, you will see the effect of the include layers. So sometimes I would recommend like your largest scans or your base scan to put at the bottom, and then the layers that you had over time to have them on top. But depending on your situation, sometimes it's less work to put the layer at the bottom and redo some inclusion box. So it really depends on your situation.
Yeah. So it kind of operates a lot like Photoshop or any other photo tool that has layering in there. Those on top will take precedent in that specific area. So I think we have time for one last question before we wrap it up. I know we're at 25, but I feel like we could take one more. Maybe we'll get one served up to us.
Well, there's one quickly from Cliff. Is the hosting white labeled? We do have white labeling capabilities on the platform. So on Reality platform, you can put your own logo. You will have your own domain name as well. So yeah, that's totally possible as part of the platform.
Certainly, yeah. If you have questions about that, feel free to reach out. We can certainly answer those questions as they come in. It's a pretty simple process, and there's some documentation on our knowledge base about that as well.
Yeah, really, I think to conclude, I really like that comment from Brendan. It's a volumetric Photoshop. I know Michelle talking about this a lot. It's a good example, I think, to see it where you have inside Photoshop different layers. You stack them on top of each other's, but this time we do it in 3D. So I think it really make it exciting.
Yeah, great ending comment. Let's take a wrap up on the poll. So which RealityComposer capability would have the biggest impact on your workflow? And it looks like assembling high fidelity spatial data is going to be the winner at 47%, followed by combining TLS, SLAM, and drone LiDAR data sets at 38%. Oh, we're actively still moving. I love it. But we're still in the lead with the assembly, and then cleaning up artifacts at 19%. So that's fantastic. That's good information for us to know. Oh, I think at the end,
they're fighting each other.
So yeah, so okay, so 44% combining is taking the lead over assembling the high fidelity. So that's really great. All of these are really beneficial, and specifically the one that is not getting any traction. All of that is very beneficial for us, for our R&D and our development as we move forward. And we really look forward to seeing you on the next webinar. And we really appreciate you coming out and seeing us today.
We will also be at Intergeo 2 weeks from now in Germany. So if you are present or nearby, just come say hi. We will have like a booth there. So yeah.
Yeah, stop by. Give me a shout. I'll be there.
Oh, you will be there too? Yeah, cool.
Yeah, we'll be there. Yeah. I'm very excited. It's in Frankfurt, so good times. Thanks again, guys. We'll talk soon.
Thank you. Have a good day.
Bye-bye.